I would also like to extend my warm welcome to all of our attendees, speakers, and sponsors that have come. Thank you for coming. We started planning this several months ago. It's the first time we've done something like this. That's a terrifying experience. You set up a thing, you commit to a venue, beautiful venue, by the way. You don't know if anybody's going to come. You came, you showed up. So I really appreciate that. One thing that I think is special about this year, because I think this event's going to get bigger in subsequent years. Think of this as like the first year of Spring One, which I believe you ran, right, Jay? I did. It's like the first year of Gradle Summit, which I think you ran, Jay. Yeah, so you see the pattern here, right? Jay knows what he's doing. People go to Jay. Then eventually they think they're too big for you. They do it on their own, and it's not as good anymore. But you always do a great job at running developer conferences. This is the smallest it's ever going to be. And so when we look at that speaker list, when we see Josh Long here, when we see Deshaun, when we see Mohammed from Spotify, who's I'm really interested in your topic. There's just so many speakers. You have time to talk to them, right? You know, it's not just there's 5,000 people here. You get 2 minutes of their time. Take that time to get to know them, form a connection, because this is going to get bigger. I promise in subsequent years. So this is the year to get that done. So little safety tip, you're in South Florida for all those that aren't here. You saw how it is outside. I just ask while you're here, don't get eaten by an alligator on the intercoastal side. Don't get eaten by a shark on the other side, right? That's just, just a little safety tip. What is the hack track? I'm going to elaborate on this on my own. I've been going to conferences for many years, started with trying to get raises. Rue's already let the cat out of the bag on that. But I've been to conferences for a lot of years, and honestly, one of the things I value the most is the hallway track. There could be great sessions sometimes, but I enjoy getting to meet other people, asking them one-on-one what they're learning, and kind of share ideas. I've also, over the years, done a lot of workshops where I do a half-day workshop, I do a full-day workshop, and attendees come and they bring their personal laptop, or it's like they're not ready to get the most out of it. So we really wanted to create this like really dedicated experience and set the expectation up front that like we really want to teach, we really want to learn from each other. We want to have topics prepared in advance, not only Moderne and Open Rewrite, but the Azul guys will show you a lot of things about operating JVMs efficiently and their runtime reachability. The Diff Blue folks are here. The CodeGate guys are here. The Sneak guys are here. There's a lot of different things you can learn from this population, and I hope you avail yourself of that opportunity. I like to write code, hands-on keyboard. I want to write code with you. So I hope we get to do that while we're here. Don't be afraid to come over there and spend as much time there as you can. So I think today I'd like to just address what I think of as from our perspective, what we see as the trends in AI for large scale software impact analysis and transformation. I'm going to start with a quick little demo video, and then I'd like to decompose it a little bit into what's actually happening behind the scenes, because, if we're all trying to build agents in various ways, and I want to show a little bit about what we've learned over the last few months as we've done that. So just to show something right now, I would introduce you here to a desktop client, yet another one. I think this is the new thing, right? First of all, everybody's going to have a desktop client now. This is like 1998 again, right? We call it Modi. Modi is a large-scale, multi-repository agentic AI system. So the idea is that you don't just point this agent at one repository that's open in the IDE, but you point it at a business unit. So that could be dozens, hundreds, thousands of repositories potentially. And when we do that, we're pointing it at enriched data about that code, not just the text of it, but everything the compiler knows, all the dependencies. That's what we call the lossless semantic tree. And so I start by asking some sort of question. So in this case, we're asking, what version of Java am I using? It's actually a surprisingly hard question to answer because, in the Java ecosystem, there's actually no standard way of specifying what version of Java a particular repository uses. In fact, there may not be a signal of it at all. What we've done here is now, if I just ask a large language model, what versions of Java am I using in commercial bank right now? Of course, that's not in its training set, right? So where is it going to get that information from? The big change over the last 6 months or so has been the introduction and the promulgation of tool function calling, which enables models to exercise tools to retrieve data for them at just the last minute to enrich their knowledge set with something. So what we've done here is taken the thousands of open rewrite recipes that exist in the recipe marketplace already and exposed all of them to a large language model as tools it can use in various different combinatorial ways. And so already a teaching point here at the very beginning, I've got thousands of tools, but if I look at the API documentation for a common foundational model right now and ask how many tools can I expose to it, it's usually limited to like 100-ish. So how do I expose 4,000 things when I can only supply 100? I need to put a tool in front of the tool. And the tool in this case is a recipe search. So before you start to try to do anything, first ask me what recipes exist that would try to accomplish the thing that I'm asking about. So that's what you see this model doing right now. It's trying to find recipes that would help it understand what Java version is in use. It found, just 10 recipes. Maybe it always selects a population of the 10 most likely recipes that meet that criteria. And then it's going to examine them in closer detail. Look at the recipe options, look at the description text on it, look at the data tables that are produced by that recipe, read their options, learn more about it. And from that point, from this narrower set, so we're just kind of funneling it down, right? Narrowing it down. It sees that this is a good data table to use. It's going to start executing that recipe. And so this has become now there's a deterministic machine running in the background, extrapolating all this information about what's in use. And the first, several results that come back from that run show, this repository is using Java 8, this one's on 17, this one's on 11, this is so on and so forth. A key learning that we've taken away from doing this for a little bit is that the more structured you can make the output that you provide from a tool back to the model, the better. In this case, you can see it very much looks like a table. Tables are boring, they're easy to read. You can describe the columns. It's very easy for a model to latch on to something like this and learn about it and reason about it in some way. But in theory, a recipe could produce millions of rows of data, and you're going to have that problem of how do I reason about all that data all at once? So we expose yet another tool, which is just process that data table with a SQL query. Models are pretty decent now at writing basic SQL queries if they understand the structure of the data that they're looking at. And so if you look closely here, you'll see that the model decided to select the source version, count star as count from this, group by this, order by this, and it's effectively reduced the cardinality of data that it needs to consider down to just the distinct versions in use and their counts. Now that is something that a model can really, focus on, right? Um, Ultimately, all of these tool calls are looking to result in some textual response. And so the textual response here would be something like, okay, now that I've gotten all this data, I've sort of understood, this is the summary. I could now say conclusively, this is the versions in use. This is how it's kind of laid out across the organization. And this is the beginning. I think this is, and what you call sort of beginning of an agentic experience for large-scale impact analysis. A model could choose to run multiple recipes, select multiple data tables, use them in different combinatorial ways, make changes, et cetera. And this is, I think this is the sort of the result that we wind up with. So this is Madi. Here we are at this point, at this crossroads a bit. Tool function calling is only 6 months old-ish, or at least in sort of popular use. You've probably seen Anthropic promoting the model context protocol now, which seems to have gained a little bit of momentum behind it as a standard way for us to expose tools to LLMs for them to use. And in fact, many products, from code assistants to the chat desktop applications themselves, are now supporting you providing MCP servers. So basically, you expose tools to them for them to use as they choose, to answer certain kinds of questions. I think there's an interesting point here of, when should I decide as a product company to own the experience as a first party? Like, should I build my own desktop client? Should I own the user experience? Or should I just expose my product as an MCP server and make the primary experience be that of ChatGPT desktop or a code assistant in the IDE? We're in this weird moment where, like, I don't really know what the right choice is exactly. And as I go to build an application like this, I think I've got a classic architectural question as well, which is, should I build a 3-tier layered architecture or a 2-layered architecture? So what I see out there in the wild more often right now is this 3-layered architecture, where I build some sort of UI like a desktop application. I build a separate MCP server, and then I have some sort of API or CLI underneath the covers that's actually doing the work, that has the data, that has the really interesting, ownable data that the model doesn't know about. And if I were to ship this kind of like 3-layered architecture, then I would expect a human user to use my UI that's built on this like layer cake. But I could also allow agents to attach to my MCP server component as well. And I think we're currently thinking right now on May 12th that there's really no benefit to separating the UI and MCP server, because after all, that application that you were seeing earlier with the UI, in addition to executing the tools itself and serving the UI, can also just expose itself as an MCP server. And so there's this interesting world where these tools that we're building should also have UI that is self-describing and how to use them and what benefit you're going to derive from it. And so I expect for a little while, this is how we're going to continue to develop. We're going to continue to develop with UI and MCP server together. And our ownable technology, the CLI behind the scenes or the API behind the scenes, will be the only separate component. But I'm curious, as again, I would love to hear what you're doing out in the world. So this is one of the discussions I'd like to have. Are you pursuing this 3-layered architecture, the 2-layered architecture? Kind of how do you see this shaking out? I think it's one of the things to discuss this week. The thing about these models, of course, is that I think we're entering a world where the model itself is really a commodity. We've been testing Madi with both Anthropic, OpenAI, Gemini, et cetera. And honestly, the distinction between the models is not that great. It could kind of like one's slightly ahead of another at any given moment, and they switch pole position at any given moment. But the tools that you provide to them are really the long-term ownable experience that causes a model to feel differentiated from another. So I'll try to provide a little bit of like understanding of, I think, as vendors that provide unique data or unique IP, how can we work together more efficiently to jointly expose this information to models in different ways? And I'll give you a couple examples of this, of folks that are here with us this week. First of all, we have the Diff Blue team here with us this week. they'll be at the hack track, showing off their technology. The Diff Blue team over the years has built up, using reinforcement learning techniques, a mechanism to synthesize new unit tests for code that is not well covered by unit tests. And so you can probably imagine the connection to what we're trying to do at Moderne is large scale application modernization and security vulnerability repair. A common objection we get is, how can I be more confident in changes that you're proposing to me, even if those changes are produced via a deterministic algorithm? Complex application modernization and tech realignments are often held up by that lack of confidence. And so what we've done with them is build an open rewrite recipe around Diff Blue covers ability to generate or synthesize new unit tests, so that we can deploy it in the service of better coding parts of the application with unit tests that we're about to change. So I love these kind of better together sort of things. We each come with these like ownable, unique parts. And now through something like Modi, I could ask a model, which parts of the code are not well tested? What can you do about it? What can, and you can imagine the chain of machinery here, from me asking a model to better code the test, to the recipe running, to Diff Blue cover actually synthesizing the tests underneath the covers. I think this is a really cool world where we can do that in a multi-repository way. There's another, there's another integration that's entirely different. So just completely different concept. As we all know, organizations have hundreds of millions, if not billions, of lines of code under management. We know all of that code isn't used, right? I'm sure I know that I have code in my own code base, even though we're not that old of a company, that is not being used. And so we built an integration with our friends at Azul, who are also here. Azul, of course, has for a long time built a unique JVM with better performance characteristics, really fantastic service they've done to the Java community over many years. They also have a new product now called Azul Intelligence Cloud that collects up runtime reachability information about the execution paths that are demonstrably ran in production. And so by stitching the information that Azul knows about data that's or the code that's actually being executed back to the lossless semantic tree of like where classes and methods are, we can build a recipe that progressively deprecates, elevates the severity of the deprecation, and then eventually removes unused code paths from our code base. I've never seen that kind of machinery of like systematically purging dead code paths from our code base, which means less stuff to maintain, less stuff consuming resources, less potential attack surface area, etc. The joke for us, I think, is this is actually an image of this running on our own code base. And the deprecation here is to a feature that we debated whether or not to create. In fact, isn't used super frequently. So kind of like, it was interesting to see that one pop up as like the first example of, a path that wasn't used, at least in one of the tenants. But so now we've talked about two very different things. One is about like, synthesis of completely new things. One is about stitching runtime information, which is always moving back to the source of truth of code in the form of the lossless semantic tree. A completely different integration that I think is super interesting, and we have folks here from Vulncheck, is to try to, let's find and fix vulnerable dependencies, right? In the same way that which means I need to upgrade a dependency, which means I need the machinery to be able to upgrade dependencies. Open Rewrite does really well at upgrading dependencies in idiomatic ways, depending on what the build tool is, whether it's Gradle or Maven or npm or which version of it and how is it going to do it as transitive, etc. But I think what's interesting about companies like Volncheck is that they're enriching the basic NVD with additional data, like in their case, um, whether a particular vulnerability is demonstrably commercialized or weaponized by nation state actors and in use by those threat actors to actually actively try to exploit things. I've never seen anything quite like this before. When I think about this kind of data source, what I think is prioritization and severity, right? I would look at a demonstrably weaponized exploit. And so I've kind of filtered it in this case to just weaponized ones and ran it and have fix suggestions. And I would say, like, I probably need to get these fixed pronto, like right away. Then maybe I can, through, another pass, move down to just commercialized exploits, fix those at a sort of different cadence, and then I'll fix all the other ones on maybe a different cadence. So I like when there's data sources like this that allow us to not be idealistic. Even with the machinery to make large scale change, somebody still has to review that. Somebody still has to accept it. If I can limit the scope of the change to the things that are most important right now, it's more likely to go through. There's one more conversation I would love to have this week with you, and it's to have a real honest conversation about technology lifecycle management for EOL software, for end of life stuff. The question that we've been wrestling with internally for years now is, should you push forward to latest versions or just backpatch old versions of libraries to stay secure where you're at? And I think you see kind of both solutions in the market right now. We've for a long time been very focused on, at Moderne, getting you forward and making that getting forward not so scary, to make sure you're on the latest versions of everything, which are going to be naturally secure and not end of life. But we do hear, kind of out in the market that there's portions of the code that, for one reason or another, we're just not ready to move forward. And so at Moderne, we've started offering now backpatching services where our technical account managers that work inside our customers with code access are able to provide backpatch versions of libraries for not just Spring or not just uh, Tomcat or something, but the entirety of the open source, footprint that that company is exposed to. But there's some questions I think still about how best, if I were to provide a backpatch version of a library, to actually deliver that into the code base and make sure it's used, right? Because just providing a backpatch library, work isn't done yet until that patch is used everywhere it needs to be used. So we have this kind of complex story, right? Which starts with, well, first of all, I need to understand the version spread of how a library is used across the business unit. And so we've had for many years now open rewrite recipes that are able to dig down into direct and transitive dependencies to look for how they're all used and then categorize them in some way and plot them. And then we think that there's obviously the recipe that we've worked on for many years to actually rev the dependency, which seems like a very easy thing to do. It turns out to be a very difficult thing to do in general. You may be familiar with like a dependabot or renovate. Those unfortunately do the kind of easy things. They update the direct dependencies. But oftentimes fixing or actually moving forward to a later version involves me revving a transitive dependency. And how you do that is very situational depending on the build tool that's in use, the version of it, and everything else. So I have these two pieces. What's in use right now? How would I even get to that later version, that patch version, if I wanted to? And then there's a third thing that I think kind of fits into this story as well, which is sometimes we encounter 0 days like this, Spring Security 0 day on a default insecure CSRF policy that affected all versions prior to 5. And how difficult would it be if I had a backpatch version of like every minor and major release of Spring Security back since the beginning of time, and then had to apply the right patch on top of the minor for kind of like depending on which minor or patch version or major version a particular application is using. That sounds kind of like a nightmare. And the alternative in this specific case would be that we just run the simple recipe that does nothing but changes this one line of code to like invert the defaults at CSRF policy from insecure to secure. And I could do the same change for every version of Spring less than 5 and not go through the like really complex exercise of trying to understand this one needs 4.7.1, this one needs 4.6.1, this one needs 3.8.1, this one's, so you see what I mean? And somehow in this is why I want to have a conversation about this with you. In this slide, and this slide, and this slide, and this slide, I can't describe this complexity and nuance to you in like 8 words. So I would like to hear what you're doing about technology lifecycle management for EOL software, for us to share ideas on that, to hear kind of what your plan is and what you would like to do. These are topics that are very, near and dear to my heart. I hope this gives a bit of a glimpse of the kinds of questions that we can ask, that you can ask jointly between like ourselves and Sneak or ourselves and DiffBlue or somebody that's here, and see if we can craft solutions that stitch together different types of data to do really interesting things that I think I'm not thinking of right now. That's what I'd love to see. I believe this is true, that if you walk out those doors, there will be things out there. There's a yes. Thank you.